All right. So we are going to do all the problems using the shortcut. If you haven't watched the video yet, that's okay. Then you'll kind of see where this comes from. If you have watched the video, then that's great because then you've already seen a few examples. All right. So let's go ahead and do the very first problem. So if you've seen the video, then you know that anytime we have something like this within a complex fraction, we want to make sure that each of the pieces of our complex fraction are all written as fractions. So what we would do is we would take the m, and to write it as a fraction, what would we do? We'd put it over 1. Okay? And then we'd want to figure out what the common denominator of all of the fractions is. And in this case, 5, 5, and 1, the common denominator would be 5. So the common denominators today are going to be a lot simpler than the common denominators were yesterday. They're not near as complicated as they were. So now what we're going to do is we're going to take this and we're going to multiply by the common denominator over the common denominator. So we're basically taking the complex fraction and we're multiplying it by 1, right? 5 by 5 is 1. So we're changing what the problem looks like, but we're not changing what it equals. It's going to equal the same thing, okay? It's going to look different, but it's still going to equal the same thing, okay? So the 5 is going to multiply by this fraction. It's going to multiply by that fraction. That's for the top. And then on the bottom, it's going to multiply by this fraction. Okay, so I'm going to show all my work, and after you've done this a few times, you can show less work. But for right now, I'm going to show all of my steps. So this was me taking the top and multiplying the first fraction by 5. You can see there's me showing my work. I multiplied the first fraction by 5. Here's me taking the second fraction and multiplying that fraction by 5 and showing my work. And then on the bottom, I have m over 1, and I'm multiplying that by 5. You can see me showing my work there as well. Okay, so if we have a divide by 5 and a times 5, what happens? They cancel. Divide by 5 times 5, they cancel, okay? Down here we have a divide by 1 and a times 5, so those are not going to cancel. Yeah, okay. So up here we have nothing to distribute, so we just have m plus 3, correct? So m plus 3, okay? We have a plus sign, not a minus sign, so we can just keep adding here. So plus 4m plus 2, because the 5 is gone, so there's nothing to distribute. And we have an m on the bottom. So what just happened is we went from 3 fractions, 1, 2, 3 fractions, to 1 fraction. Oh, sorry, 5m. Sorry, 5m on the bottom. My bad. M times 5 is 5m. My bad. Okay. Now, if I look at the top, are there any like terms I can combine? Yes. I get 5m plus 5. Okay, I'm going to draw my work up here. So 5m plus 5. Did you just tell me to kill a puppy? Cancel the 5m's? You cancel the 5m's? Cancel the 5m's? You want me to kill that puppy? Oh no! Let's not kill the puppy. Okay, so we're going to... There we go. We're going to take out the GCF and not kill a puppy. Oh, man. That puppy jumped out of nowhere and you shot it dead. Take out the GCF of 5 and don't kill that puppy. That puppy's running across the street. We are stopping our car. We are not running it over. Oh, don't do that. I know, but you stop the car and you let it run.
No, I said I almost. I said I did.
And you keep it safe.
I almost hit a squirrel and like super
Yeah.
I hit it. I went right over it.
Oh, yeah. Don't close your eyes. That's not good. All right. So what happens?
Now you can cancel out. You can cancel out your 5.
Cancel the 5s.
M plus 1 over m.
And do we cancel the m's? No. No dead puppies.
I know we don't cancel m, but why is it?
Because there's a plus there, and plus and division don't cancel.
Don't mix your signs.
Don't mix them. Okay. Okay. Let's try number 2. All right, number 2, it's got a 25 all by itself. The 25 is not a fraction, so what should we do with the 25? It's because it's a plus problem, and if we cancel a plus problem with division, then we're saying that plus and division are opposites of each other.
Should we just leave the 25 okay?
Yeah. Well, now you remember. Yeah. Okay. All right. So number 2, what are we going to do with the 25?
Just leave it.
Not just leave it. We're gonna put it over 1. We're gonna make it a fraction. Okay. Put it over 1. All right. So we got a fraction, a fraction, a fraction, and what is our common denominator? We got a 1, an m squared, and an m.
Just an M.
M squared.
M squared, because if m and m squared got in a fight, m squared would win. It's got more m's, so it's 2 m's against 1. Okay. All right, so m squared. So we are going to multiply by m squared on the top, and we're going to multiply by m squared on the bottom. So on the top, we have 25 over 1 times m squared. We made it a fraction. We want to make sure whenever we deal with our complex fractions that every single piece is a fraction. It was, and then we said this is a complex fraction, so let's take that 25 and put it over a 1 and just make sure every single piece is a fraction. So kind of like on the last problem, we had a plane m, and we took that plane m and we made it a fraction. We put it over 1. We did the same thing with the 25. We just want to make sure when we're dealing with complex fractions that every single piece is a fraction, because we have to consider the denominators of each piece. Yeah. Okay. So 25 over 1 times m squared, and then we have 5 over m squared times m squared. So this is me taking the bottom now, and I'm distributing the m squared, plus 20 over m times m squared.
Do we have to? Oh yeah. We do. I'm thinking about yesterday because I was like, do we have to multiply the 5 over m squared by m squared if it already has it?
Okay, so are there any questions? Are we seeing exactly what we're doing here? We took the common denominator and we're multiplying it by every single piece on the top and the bottom. We got it? Every single fraction on the top and the bottom has been multiplied by the common denominator. We're good? Okay. So when we multiply the common denominator on the top, what do we get?
25 m squared.
Okay. Okay, and then on the bottom, the m squareds cancel. So we have 5. And then 1m cancels with 1m, and it leaves 1 behind, so 5 plus 20m. Okay. Now, we have, if we think back to the very first day of the unit, this is written as numerator over denominator. Is it written in the correct order?
No, it's not descending.
No, it's not descending. Okay, so the top is fine because that's only one term, so we're just going to leave that, 25m squared.
We have to do 20m minus 5?
20m. Is the 5 positive or negative? Positive, so we're going to put plus 5. So, no, since you carry the sign with the term. So since the 20m was positive, we put just positive 20m. Since the 5 is positive. So if you are rearranging terms, you keep the sign with the term. If you are moving something to the other side of an equal sign, then you do the opposite to move it. Yeah, good clarification. Okay, so the top is going to stay the way it is. What should we do with the bottom?
You should factor.
Take out a 5. The top is a perfect square, which is good to notice, but in this problem, it doesn't actually help us. Yeah. But we can take out a GCF of 5, and what does that leave behind? 4m plus 1. Okay. And then what happened? So we can't touch the parentheses because that's only on the bottom. But what about the 5? The 5 and the 25 can reduce. Yeah, okay. So 5 divided by 5 is 1. 25 divided by 5 is 5. So 5m squared over. We don't need to write the 1 because most people don't put that. We can just put 4m plus 1. Okay. Okay. My plan is just to keep going until you guys are like, Miss Rice, stop. We get it.
Okay.
Okay. Let's try number 3. No. No. Number 3. What's the common denominator? 5. So we gotta. So this one's different than 1 and 2 because on this one, each of them were written as fractions this time. And so we didn't have to turn any into fractions. So we've got a 5a, we've got a 5, we've got an a. So 5a. Okay. Okay. So I'm going to multiply by 5a over 5a. And then I'm going to multiply it by each piece. Yeah, one of them has a 5, one of them has an a. And so because of that, we need a 5, we need an a, and then the other one just has 5a altogether, so. Now, I keep writing what I'm distributing on the right side, but we could write it on the left side if that's how we want to distribute stuff, because on this one, we're not going to cancel everything. Are you guys okay with that? I just switched my 5a to the other side. I just moved my 5a over. Okay. So for the top, 5a and 5a is gone. Okay. So on the top of the fraction, we just have a minus 5, so that's pretty simple. Okay. On the bottom, the 5 cancels out for the first fraction, and then we have an a left over, and we do need to distribute that a. And so what do we have?
A squared minus 4a.
A squared minus 4a. Okay. And then for the second fraction, we have the a and the a. Those cancel out. And now we have to be careful because we have a negative 5. And the negative 5 is distributing. And then positive 20. Okay. Are we okay with that?
Combine like terms and then factor the bottom.
Okay. It will be factorable. Okay. So we have a minus 5 over a squared minus 9a plus 20.
Factor 5 and 4. So a minus 5, a minus 4, because the 2 negatives are positive.
Okay, so we're multiplying to 20. And adding to negative 9, so negative 5 and negative 4.
Negative a minus 5 and a minus 5 are going to cancel out. So then you can get yourself left with 1 over a minus 4.
You guys are so speedy. Has anyone been checking these to see if our answers are on the back? Yeah? Have they been?
Oh, jeez.
The punchline today is really good. I'm very excited for you guys to see it.
Did you create it yourself?
I mean, I found the jokes and I was like, oh, that's a good one. That's the one I'm going to use. Okay, now at this point, let's stop doing them in order and let's look for a specific problem that might be scaring us. So, can anyone find a problem that maybe feels intimidating where you're like, Miss Rice, no thanks? 13? Okay, 13 feels not great. Oh, let's actually do, before we do 13, let's do number 11 because I remember number 11 not being great. So let's do number 11. Okay, if we look at number 11, okay, let's do as much as number 11 as we can. Okay, number 11, can you guys tell what the common denominator is? Okay, so we need a 9, and then we need an m squared because we got a single m, but then an m squared right there, so 9m squared. Okay, so we're going to multiply by 9m squared over 9m squared. And we have all the fractions here. They're all written as fractions, so we don't have to put over 1 for anything. There's so many m's and 9's in this problem. Okay. Okay. So on the top, we have 81 minus, no, there's no 9, just m squared. Okay, and then on the bottom, we have an m minus 9 times m. Yeah. Okay, my helpful hint is on the top, it's in the wrong order. You got to fix the order, and the first term has a negative in the front. You got to take the negative. Switch the order, take the negative out. I am not going to be here tomorrow after school. I'll be here during school, but I won't be here after school.